Well, welcome everybody. Thank you very much for coming to this unique event. My name's Mark Bergman. I'm at the University of Melbourne. I have the great privilege of managing these two guys for the next hour or so, unmanageable though they may be. The first speaker is Professor Ian Chubb, Australia's leading scientist, the chief scientist of Australia. I was reminding myself of his accolades on Google just before he came in, but they're just too many to remember. And perhaps the most relevant for today is that he's been Chief Scientist of Australia since 2011. He's a graduate of Oxford University and one of Australia's great scientists, Ian Chubb.
Thank you very much, Gordon, colleagues. It's good to be able to talk to you about the role of science, especially science in the environment, a very topical issue. I gave a talk today out at DSTO to a bunch not unlike you, maybe some of you there, and I said that since the sun was shining, people would say climate change isn't happening, and since it was cold, people would say climate change is happening. And that's actually about the level of the scientific debate that we have in Australia about climate change. So one of the important things I think to talk about is how science does interact with and engage with and indeed influence public policy. So what I'm going to do is to give you a little warm-up and then cite some particular examples where I think we need to make sure that we've got our act together as a country rather than just as committed and dedicated individuals. So for those of you who don't know, my role as Chief Scientist is to be both an advocate for science and a channel through to the government for science advice. Of course they are related because a community that values science is in a position to act intelligently on the evidence that science provides. And that is indeed, I believe, to be the key. Because everything that we do in science or in government is ultimately a means to an end. And I think one of the things that we've done regularly in Australia, certainly in my memory, one of the things that we've done is confuse means and ends. So for example, if you were to arrive on planet Earth from somewhere else in the universe over the last year or so and just confined all your information to what you saw in the media, then there are two conclusions that you would draw. One is that Australia is just an economy that can't be in debt. The other is that most of what you read in the media is wrong. So we can't actually be just an economy that can't be in debt. We actually see the economy, I see the economy as a means to an end too. So what sort of Australia is it that we're trying to build? What is our aspiration for the country? What do we want it to be? With all the potential that we have, what could the country be if we got the means right? The economy is one of the means, but it's not the only, it's not the end game. It's a means to that end about building the country that we want to build. Science is another one of the means. Science doesn't exist on its own. It doesn't exist in isolation. It doesn't exist outside of a context. The context is the context of this country and its community and the world. So we have to use science, we have to employ science to be able to support our community and to help us build the sort of country we want to be, because it's a means and not an end. And we also have to make sure that Australia can play its part, its role, in what's happening in the global, on the planet. And that means that what we have to do is to set our aspirations, I think, high, work out how we support what it is that we need, and I'm going to concentrate on science obviously, but how we support our science and the sort of science we support to help deliver the end game. Now, when I was a young scientist, I probably, like most young scientists, thought that what I did was enough. It's what the end game was, really. Me getting another research grant, having another PhD student, employing another postdoc, getting some good papers published in highly reputable journals, and that was the end game. But as I've got older, and I hope wiser, that I see that in fact all I was a part of the puzzle. I wasn't the final jigsaw puzzle completed, I was a part of the puzzle. And I had to now, I believe, that we've got to make sure that we support what we need to support in the manner in which we need to support it in order to be able to say that we are making a contribution to that end game. And if we painted the big picture well, we'd all understand a lot better why some of the political decisions that are made, because they actually do look at life, the things, the issues that confront us through a different prism, rightly so. But we would better understand why some of those decisions are made if we knew what the whole end game was going to be. And I don't think the end game is simply and exclusively an economy without debt. So, as I've said, science is a means, innovation is a means, the economy is a means, and the policies that we develop are all means. And we've got to work out what we want them to do and what picture we want to paint. So, in that spirit, and that spirit only, I think that more of our national conversations would make sense if we approach them as scientists. Now, you would expect me to say that. Indeed, one of the economics commentariat, who writes a regular piece for one of the newspapers, ended one of her last pieces by saying that the government should stop talking to self-seeking scientists and to talk to a rational economist. So I've been trying to find one. So I'll continue to talk as a scientist. But I think that some of the things that come out of the exercise, when you think about it in the way that I do and I must and by instinct do, if we approach some of those national conversations, and I made a joke that fell flat about climate change when I started off talking to you, but we just think about what passes for debate and how easy it is to frighten people with limited scientific understanding and literacy about the consequences of having to do something about that and the consequences on them for having to do something about that. So if we were able to think critically, argue objectively, working collaboratively and building creatively, as scientists often do, the best scientists often do, and I'm not going to pretend to you right now that all scientists are perfect, but if we did that, and always with a view to the end, I think we would have more sense in our national conversations. So I also want to say that when I challenge audiences to think of the big challenges that confront us as a community, indeed the living systems on this planet, to think of any, and how many can you think of, that don't have science embedded somewhere in the core of the response. Whether that response is understanding better, understanding more, whether that response is applying knowledge to do something better, to do something less dangerous, whatever it might be. Just how many of them don't actually require some science at the core? I can't think of too many. I'm sure there are some, and I guess as a self-seeking scientist, all of the ones that I can think of have science at their core, whether it's from pandemics to the climate, whether it's about vaccinations, the spread of disease, antimicrobial resistance, lack of facility of antibiotics in the future. All of those things will require, and very significant things, millions and billions of lives depend on them. They will have science at their core. And I want, when science comes up with potential solutions, I want the science to be discussed rationally, systematically, carefully, and the community to make a decision about whether or not we go ahead with a particular path that science would let us go. Tony Blair once said when he was still Prime Minister of the UK and had talked to the Royal Society that science will let us do more, but it won't tell us whether doing more is right or wrong. So we've got to feed our science into a process, we've got to feed our science into a context, and the community that we engage with as scientists will determine whether doing more is right or wrong. And we want them to be more often right when they make the decision than wrong. And that actually means taking them with us along the path taking them with us along the journey. It means engaging in ways that we never had before. So broadly, in order to achieve that, I think that there are three things that we need to be the sort of nation that we could be or that we might aspire to be. We need science in the areas where we actually need it. We need science-trained people everywhere, and by which I don't mean scientists, but I mean scientifically literate people in all areas, because we need them there in order to have the rational conversation. And as a consequence, we need science-informed people making intelligent decisions. And in that category, that's the community. We should have a high level of science literacy in the community. So let me draw out the points using some examples that are directly relevant to some of the work that you will do. Let me begin with the Great Barrier Reef. The context is that the risks to the health of the reef and associated ecosystems stem from a range of human activities. They include nutrient runoff, coastal development and shipping, illegal fishing. Longer term, of course, the global carbon dioxide emissions are causing ocean acidification, and they're decreasing the ability of shell-making animals and plants to build the reef structure. The warming of the oceans is leading to coral bleaching. We've made progress in easing some of the pressures on the reef, such as runoff from land and dumping of dredge spoils, but we have the ambition and now new funding to help us do more. So how are we going to use it? So, do we have the science capability where we need it? The reef is huge, and our capacity in marine science, though good in parts, is limited to a number of institutes, reasonably sizable number of institutes, many small agencies and groups of researchers. So we need a fundamental understanding of how the reef and its connected systems interact to be able to respond to multiple and cumulative impacts, such as ocean acidification, crown of thorns starfish, nutrient runoff and so on. So we need benchmarks, we need long-term monitoring, and we need to know if the policies we put in place to protect and restore the reef are having the intended effects. And who will do that for us if we can't do it in Australia? So, the next one, number 2, do we have enough people deploying science in all the roles where science is required? So our capacity to protect the reef relies on action informed by evidence across many industries. Just as there are many threats, there are many people, and we would want to motivate and motivate and make a contribution. So the Reef Trust has done something about it. They've been dealing with gully erosion in the catchment. They've been limiting nitrogen runoff from fertiliser. They've been helping graziers to reduce their impact on the environment, tackling hunting, poaching and marine debris to protect turtles and dugongs. But we need science expertise in government and the capacity to apply science in every industry, from agriculture to fishing to tourism to transport. That is recognised in the National Science and Research Priorities. Question then is, the third one, do we have a science literate community? Well, I think it's necessary in discussing the reef as it is in discussing other environmental issues. We need the understanding of risk, of basic science, and of the difference between evidence and opinion. We seriously need people to understand the difference between evidence and opinion, as we need in discussing climate change, our management of water, our decisions around exploitation of energy resources, such as coal seam gas and other issues of national importance. But there is another important role a science literate community can play, because the reef and its connected systems are so large and complex. Established science organisations are pressed to study them continually and in their entirety. So citizen science, which is one of the issues that the federal government is, I think, beginning to take up, has a significant contribution to make through the provision of much data. Another example I could give you is antimicrobial resistance. World Health Organization has told us how bad it's going to be when the last of the antibiotics that we're presently using lose their effectiveness, and the millions of human beings that will die as a consequence of being unable to treat effectively the diseases that we effectively got rid of with the introduction of antibiotics, and things like the scratch on my hand, which led to the first individual ever to get septicemia, who pricked his finger, scratched his hand, pruning his rose bushes, got septicemia, was treated with 1 dose of penicillin, radical improvement overnight, but they didn't have enough to give him a second one, so he died. The scratch on the hand led to that person's death, and he's famous of all the people who died under those circumstances because he got one dose of penicillin but didn't have enough for two. So we are looking at a situation where those sorts of problems will re-emerge. We need the scientists to do it. We need the scientists in government or the science advice to government to be able to build good policy off the back of that, because are we going to sit by and say, this is too hard, we can't do this? Much more important to have an economy without debt than it is actually to think about what we're doing as a consequence of some of those decisions. I don't think we can afford to do that. So we need the right people, we need the community, we need the level of literacy, we need people like you, all of you, I bet, and me too, have been given a course of antibiotics, and as soon as we felt well, we forgot to finish it. We have contributed to antimicrobial resistance through our own personal actions. This is not going to serve us well unless we now get the right people in the right place, doing the right sort of research to produce the right compounds that will put to death some of those microbes that cause us much grief. And we know historically how much grief they caused. Nuclear power. South Australian Royal Commission, you know all about that, and you know much more about it than I do. But if we're going to have a serious discussion about the consequences of that review and the consequences for Australia of considering whether or not nuclear power was part of the energy mix for the future of the country, we need to be able to have a rational debate about that. We need to be able to get people who actually understand what it means. We need to get to be able to have a rational discussion with people when we talk about a nuclear waste repository. Why is it that we would prefer to keep nuclear waste from the health systems in suburbs of Sydney rather than find a better place in this huge country, a better place and a safer place to store it? We don't have the level of discussion that we need. It's going to grow if we have a consideration of nuclear energy as a part of the energy mix. I'm not an advocate for it, I'm not an opponent. I'd like to see the discussion. We will have a discussion when the South Australian Royal Commission comes out, and I'll bet you that I would put $10 now on what the nature of that discussion will be. There'll be some out there beating the drum loudly in favour, and there'll be some out there beating the drum loudly opposed. Will it be rational? Maybe. Will people who are not versed in the nature of science and the processes of science be made anxious by it? Almost certainly. How do the politicians react to that? This lot beating the drum, this lot beating the drum, and in the middle a whole bunch of anxious people made anxious by some part of that process. This is not a good outcome. We think of nuclear energy, let's say hypothetically that a government decided to 20 years time to build nuclear energy right now, to move to nuclear energy as part of the energy mix. What would be the consequences? Do we have enough people studying physics in Australian universities to be able to cope with that? Or nuclear physics? No. If we're going to do these things and project out here, we've got to remember that this is part, close to the end, of a long pipeline. The people who started school this year will still be in the workforce in 2070, assuming we've still got a workforce in 2070, but they'll still be there. How do we prepare them? How do we prepare for the uncertainties? How do we actually begin to figure some of the things that we might need to be able to build into policy that positions us for the medium to longer term rather than through the electoral cycle or just past the next election? So I think that all of those things require scientific thinking, they require scientific contributions, they require people with scientific knowledge to be able to discuss and to make informed decisions, and they need those people to influence politicians to make sure that some of our projections, some of our commitments, some of our policies endure beyond the lifetime of an Australian Parliament, which on average is 2.7 years. Because these are long-term things. They're about building a country. It's about making sure that we've tailored the means We've structured the means, we've supported the means and identified the means to get to that great end. And that's the end that we should be aspiring to reach. Thank you.
Thank you very much, Professor Chubb. We'll have an opportunity for questions at the end, so I'm sure you'll have some. Keep them in mind. But before we go to questions, we've got Dr. Gordon de Brouwer. He is the Secretary of the Department of Environment. He's an able, experienced and very influential public servant. He comes to us in the Department of Environment from Treasury, from Prime Minister and Cabinet. He has a career in the public service, and he may have the unique characteristic of being the world's only rational economist.
I knew there'd be one.
Thank you very much, Mark, and it's a great pleasure to be here and to be here with Ian as well. And I just start by acknowledging pay my respects to traditional owners. It is a great pleasure to be here. I'd like to talk about three matters around science and the environment. The first is about the role of science, among other disciplines, in the work of my department, of the Department of the Environment. The second is the importance and practical use of science in decision-making under uncertainty. And the third is to explore further opportunities of scientific discovery. So it's really to open up a conversation about some more work. So I might just, with the Environment Department, we support the government in managing Australia's natural resources estate. Now that's big. That's land, water, marine and reef systems, biodiversity and heritage in Australia and Antarctica. We do that largely through the lens of understanding and protecting the environment and implementing environment policy. And we do that through a range of instruments from programs, regulation and on-ground operations. So it's a big task. By basing our work on the best available evidence and framing it to the challenges of the day, we seek to perform our responsibilities in ways that achieve the desired outcomes, that are well-informed, credible, impartial and practical, and that retain the trust and confidence of both the government, whom we serve, and the wider community. So let me start with the role of science in carrying out the Environment Department's responsibilities. Because we're dealing with natural and physical systems, science is obviously essential to our task. Understanding animals, plants, and physical processes, which go from biology, climate, hydrology, and geology, it's a basic part of our job. We work hard at understanding current and long-term patterns in Australia's environment, both at a local and a national level, and we work with colleagues across many different parts of the Commonwealth and state agencies and research institutions. We, first of all, support information and research systems. So some of those include the Atlas of Living Australia, the State of the Environment Report, the 6 hubs of the National Environmental Science Program, and the Independent Scientific Committee on Coal Seam Gas and Coal Mining. We work on that information and research systems in order to ensure that our advice is accurate and that our implementation of policy is effective and efficient. And again, that's in programs, and that's things like Green Army, Landcare, Reef Trust, Emissions Reduction Fund, in regulation, which is notably through approvals and licensing under the Environment Protection and Biodiversity Conservation Act, and also on our on-ground operations. They can be anything from Kakadu to our 3 stations in Antarctica. So we use science alongside other disciplines like economics, law, and social sciences. And I'm sure Ian would agree that economics is an invaluable tool. So I'll go through 3 examples. These are terms like cost-benefit analysis. It's not a dry concept. What cost-benefit analysis requires us to look for is to bring the evidence, to bring the empirical evidence for all sides of an argument, and to think about what's most efficient to achieve the desired outcome, or the most efficient ways to achieve that outcome. We also look at opportunity cost. Now, what opportunity cost requires us to look at what we're giving up in order so that we can do what we want to do. So it's the opportunity cost. and dynamic consistency analysis. And that requires us to think about explicitly, are there unintended consequences from what we're going to do? Law is important. Law defines our collective responsibilities and the formal framework under which we interact. And social sciences help us to understand motivation and persuasion, and that helps us be influential and effective. So environment policy is most effective when these disciplines work alongside each other. So Australia's approach to ozone protection is a case in point. Over successive decades, we've worked with scientists from the Bureau of Meteorology, CSIRO, and universities to understand atmospheric processes and chemical substances relevant to ozone depletion in the stratosphere. Working with business and then working with other countries, we've employed an economic instrument featuring quotas for ozone depleting substances, and those quotas decline over time. And we've embedded that in national law, and it's backed by international agreement with both developed and developing countries. Finally, we've sought to understand how ozone depleting substances are used by households and businesses across the economy, and we do that to get a better handle on how to create incentives for these substances to be recycled or recovered for destruction. So in short, a multidisciplinary approach enhances science and significantly improves our ability to do our job. We don't just use science, we do it. The Department of the Environment is an investigator. Our scientists are leaders in their field, and they work on ground in places like the Australian National Botanic Gardens, in Antarctica in the Southern Ocean, in the Alligator Rivers region, and island territories like Norfolk Island and Christmas Island. We work hand in glove with scientists in universities, CSIRO, the Bureau and others, on matters like climate change, threatened species conservation, and tropical and marine science. And we do science so that we can understand natural systems better, we can provide better advice, and we can achieve better outcomes. So we're interested in the outcomes. Our work, again in Antarctica, shows this. As one example, the collaborative research between scientists at the Australian Antarctic Division in the department, the University of Tasmania, and scientists from around the world is to collect and analyse deep ice cores, which allows us to better understand the factors that influence changes in the climate on a global and regional scale and over many thousands of years. As a result, we understand better the mysteries of past global climates and, in areas like Western Australia, the drivers of today's weather. So science is really fundamentally a part of what we do. So let me turn now to the importance and the practical use of science in decision-making under uncertainty. So it's a truism that in every endeavour in life, we make decisions with limited knowledge and often with a lot of uncertainty about the future. But despite limited knowledge and certainty, we still make decisions. And often we do this in a way that allows us to review and revise what we're doing as we go along. And we see it in all priority areas, from national security to macroeconomic management to social policy. And decision-making about the environment is no different. We have some understanding of the physical systems, but it's far from complete. There are lags between action and effect, and it can take time, and sometimes a very long time, to see the impact of our actions on the environment and whether we're achieving the outcomes that we're aiming for. So there are different and sometimes complementary and sometimes competing interests in the use and management of natural resources. Our society is interested not just in environmental outcomes, but also in the economic and community outcomes, and wants us to achieve these outcomes in a balanced way that works now, but it's also good for future generations. So it's a hard task. All of this adds complexity in environment policy, and it creates risks. And just as in our own lives, in business, research and government, we manage uncertainty, risk and complexity by changing what we do as needed, so too we use practical and adaptive management to achieve desired outcomes in the practice of environment policy. So again, adaptive management of the environment is principles-based, and frankly, it's based on strong principles. Our legislation requires us, for example, to take a precautionary approach to environmental management. The precautionary principle argues that policymakers should be confident about the future environmental effects of an activity before allowing it, and should not wait for conclusive proof of environmental harm before adopting appropriate remedial measures. Our legislation also requires the Minister for the Environment to consider economic and social factors when making environment approvals. So science is an important part of making decisions under uncertainty and informs how we sequence and set thresholds for decision steps in completing an action. So I'll go through 3 specific examples: threatened species, the Great Barrier Reef, and coal seam gas and coal mining management. So I'll do these very quickly though, given the time. Just on threatened species, Australia has a great gift and great treasure of species, but we also have, with that, a large number of threatened species that is a natural part or a consequence of our economic development. We've got currently about 1,800 native animals and plants listed as threatened. So the size of our nation as well raises the scale of the problem, which means that we typically have to tackle a problem in steps and that a package of often differentiated solutions may be required. So when we consider threatened species, part of that policy architecture is that the Minister and the Department, including the Threatened Species Commissioner, work very closely with the Threatened Species Scientific Committee, the National Environment Science Program's Threatened Species Recovery Hub, and state and territory governments and others to prioritise what species and ecosystems we should seek to protect and what threatening processes we should seek to mitigate. These are empirical questions, and scientific and policy research is stimulating new and different approaches. So just very quickly, some examples around that. A lot more of the focus is on multiple species interventions, where we can tackle the threats that help a number of species rather than just one. So by tackling feral cats, for example, we mitigate a threat to around 100 different species, native species. And by focusing on green corridors, we're looking to benefit whole ecosystems rather than just 1 or 2 species. As another example, in our offsets policy, and I can go through that, there's more in the notes if you want to go through that, we're taking increasingly strategic approaches to managing offsets. So for example, we work with WA and some resource companies in the Pilbara, which is an area the size of Spain, to use environmental offsets to manage the regional impact of invasive species, particularly camels. So you can take a whole region approach, a strategic approach. We're also working with state and territory governments on how we go about listing the threatened species and to improve the scientific foundation of that listing by looking at how whether we have a common mutual assessment process, which is based on IUCN principles, and that may then lead also to a single listing per jurisdiction, but that's strengthening the scientific basis on listing. The Great Barrier Reef is another great example of how science helps frame the problem, identifies priorities for action, and develop rules and institutions to progressively tackle these problems and manage the reef sustainably. Professor Chubb went through some of the problems, so I'm not going to repeat that. But what I would highlight around the reef is that, again, we have sets of institutions, particularly starting with the Great Barrier Reef Marine Park Authority, which deeply embed science in their management. Under the Reef 2050 plan, which was the government's response to the World Heritage Committee's concerns around the future of the reef, we've got a very detailed and practical action outcome and objectives plan to manage the reef. Science is at the heart of that. Some of the new governance arrangements around that include the setting up of an independent expert panel, which is chaired by Ian, as well as a reef advisory committee to bring in broader community interest. But those groups are very important for providing advice to the government very explicitly on the success of the implementation of the plan, actions that should be updated or modified, and particularly important here, and unusually, is how the money should be allocated. So it's a very direct scientific feed into how that plan works and how it should work in the future. So the third example I'll go to, again fairly quickly, is on coal seam gas and coal mining impacts on water. So while state governments are generally responsible for managing the broader environmental impacts of coal seam gas and coal mining developments, the EPBC Act sets an additional role for the Commonwealth in safeguarding nearby water resources, both on the surface and in underground aquifers. The Act requires that before a development proposal is approved to proceed, the Commonwealth has to be satisfied that potential impacts on these water resources are effectively managed. Advances over recent years in water science, particularly geological and hydrological modelling, mean that we can approach this decision making in an informed way and can define conditions that qualify an approval to proceed. So in my notes that I've distributed, I go through a reference to 3 major coal seam gas projects underway. I just want to highlight that the approach that's embodied in there is that where uncertain environmental, in this case, uncertain environmental impacts are monitored and responded to in a step-by-step manner that is informed by science, which is the normal practice of adaptive management. Our approach to these 3 major coal seam gas projects in Queensland includes things like specifying the location of monitoring bores, which aquifers should be monitored and how frequently, and the required methods for analysing results. And the monitoring supports a series of escalating triggers, which specify actions that companies must take if those triggers are reached. So these triggers start with each project being approved to draw down water to a particular limit. If a company draws down 50% of that limit, they hit an investigation trigger, which is an early warning signal for them to investigate why they're drawing down so much water. A second trigger is set at 80% of the drawdown limit, which then requires the company to take action to halt further drawdown, which may be by re-injecting water or by retiring existing bores. And the final trigger sets an absolute limit for drawdown that cannot be exceeded. And in that case, the company may have to cease CSG production until groundwater levels return to acceptable limits. So building on that, we've set up an independent expert scientific committee, and that's chaired by Andrew Johnson and has members who have expertise in hydrology, geology, ecology and ecotoxicology. You think economics has jargon? Science has some too. The IESC provides advice to governments on the likely impact of development proposals, and it also guides the department's research priorities by identifying where knowledge gaps exist. And so it's a very important way of how we manage it. And again, the highlight there is that we have rules and institutions that incorporate and bring science into informed decision making. I'd just like to finish now very quickly on identifying and harnessing future opportunities, and especially from technological change. So this is a bit of a shift in the tone. What I would like to do is have a more detailed discussion, one-on-one or with groups and through the Environment Department or through seminars on science and future opportunities. We really see a number of big areas of opportunity that come from changes in technology. One is, for us, from technology is in big data. We have enormous amounts of data about physical systems, and seems to be in a continual process now of getting even finer detail in terms of frequency, coverage and content. And along with other agencies in government, and I think with universities, business and community groups, we need to articulate the uses of data, how we can ensure that data systems are accessible and resilient, and how we can retain the serendipity that's so important to generating new insight. The other opportunity from technology is really through the breakthroughs that can really help us significantly achieve our objectives. In recent years, we've seen technology breakthroughs that enable better and more effective environmental management, like the single bile shot that allows us to selectively kill crown-of-thorns starfish. Over coming years, we're confident that other scientific breakthroughs in pest management, like the curiosity bait for feral cats, or the use of micro-wasps to tackle crazy ants on Christmas Island, will help us to tackle major threats confronting Australia's native species. Perhaps most spectacularly, we'll also see future technology breakthroughs that break the link between economic growth and greenhouse gas emissions, be they changes that reduce the cost and increase the reliability of renewable energy, or changes that reduce or de-link greenhouse gas emissions associated with fossil fuels. I'm very interested in your views about the technology shifts or the surprises that will support the environment and how we can facilitate public understanding and a serious conversation on these matters. So I'll finish now, Mark. Thank you very much for your time. I hope you've got a clear impression that science is at the heart of the work that we do in the Environment Department, that we use science to inform and evaluate policy, and that science is deeply integrated into the rules and institutions that manage and sustain our natural environment. And I look forward to having an ongoing conversation with you about these matters. Thank you.
Thank you very much, Gordon. I should remind you, we are being filmed, so don't say anything impolite. I was supposed to remind you about that at the start, but I forgot. Now we've got about 15. Thank you very much for keeping so much to time, and thank you very much for those contributions. We have time now for some questions. Does anybody have a question for either of our speakers? Yes, please.
Thanks very much. Peter Bridgewater from Australian National University at the moment. I was, at one stage, the first Chief Science Advisor in what was then Environment Australia. I think I was also the last, which is a comment, I think, about the acceptability of science in the policy framework. The word advisor in my title at the time was also interesting because it wasn't actually something that the Minister seemed particularly interested in. But what I really wanted to touch on, following from both of the presentations, is the synergy between different activities. If you talk about and both of you mentioned the reef, a lot of the science issues there are in fact synergistic. In other words, understanding what's happening on the land as well as what's happening in the sea. So focusing on just one of those issues is not in itself helpful. So I'm just wondering what your views are on how you see the promotion of better synergy between different scientific activities, because scientists are, like most of us, very good at living in silos. And finally, internationally, there's a great movement, particularly in the environmental area, on the development of science policy interfaces. I think no one really knows what that means, but it's quite a good shorthand for how to get scientists to talk to policy makers and how to get policy makers to listen attentively to what scientists have to say. I'd be interested in your views on whether those sort of structures should actually be more prevalent within our national systems. Thanks.
So 2 questions.
Just a very quick observation around the role of science in the department. We have an Office of Environmental Science and Economics, which is headed by a Deputy Secretary. So it's incorporated very deeply into the department, and we have a specific science division. So we might not have a science advisor, but there are formal structures in the department for that. Just on the issue of the reef, and you're exactly right, Peter, in talking about marine and land management have to be integrated. I think that was the fundamental premise of the strategic assessments that were done by the Great Barrier Reef Marine Park Authority on the marine system and the Queensland Government on the land management and the land systems, that water and land go together. That's deeply, I think, fundamentally incorporated in the 2050 reef plan. So that insight is right. The reef itself is huge, but the reef plus the land in Queensland is massive. It's around the size of Europe. So it's a huge management problem, and it has to be integrated. And so that point's right. I think it is. What we've got to is a much higher degree of cooperation now between Commonwealth and Queensland governments and local governments and all the different business and community groups that are interested in that. Much more integrated approach. So that's encompassed in both the governance, but also the actions and outcomes that are written in the Reef 2050 plan. But your point is exactly right. I don't know, with the more general issues, I don't know, Ian, you're better placed.
Well, I could comment on the interconnectedness more generally. A year ago now, the present government replaced the Prime Minister's Science, Engineering Innovation Council with a council called the Commonwealth Science Council. Before you criticise it, I should let you know that was on my advice. So now you can criticise it, if you dare. But the main point of that was to sort of try to bring some coherence across the broad swathe of R&D in Australia. So to illustrate it, if you break down the R&D budget, it's around about 9.2 billion at the moment, including tax incentive scheme of about 2 billion. But if you look at that, it's spread across 14 portfolio areas and 150 programs. If you set a $10 million threshold, it's about 50 programs. So the government, I think, has accepted the notion that we do need to bring some whole of government perspective to this. Consequences of that are two. One is that in July we're about to start consultation on a national science policy as a whole of government exercise, which will include education, science education, research, international engagement, innovation. The outcome of that process will go, or the input to that process is a paper that came out of my office in September last year with a suite of recommendations about the need for a national policy. Bring some coherence to it, because it's hard to think of things that are disconnected from each other. So you have to, even if the Department of Environment and the Department of Health, they both have an interest in health outcomes of environmental change. So how you get the ministers to be talking outside a cabinet environment to think about decisions made in this department, that department and that one over there, and all have an impact on the same thing but are not necessarily connected, is an important part of the future. So I'm cautiously optimistic that all of that will work. I think the government's commitment to try to get a whole of government policy out of it all is good. The fact that Minister Pyne has announced a STEM strategy for schools, national STEM strategy for schools. I've just come from a meeting with the schools policy group of the states and territories. I think that's a real movement in the right direction. So all of those things I hope will come together and let us get to the point where we do have the Department of Environment with its responsibilities, its strategies, its priorities, embedded within which are some national priorities supported by a national policy that covers the whole pipeline from the early years of schooling through to the technological breakthroughs that Gordon referred to, and the application of knowledge and so on. And if we can get that all together in the next 6 months, we'll have done really very well. On the basis of scientific advice, I think I'm about the 8th or 9th Chief Scientist for Australia, and they've already advertised for my replacement. So I'm not the first and last in the line, and I hope that does reflect the fact that governments have now we've had changes of political party in government over that time, that they do see the need for some sort of advice coming in from somebody who is able to speak reasonably freely and publicly about some issues that have to be addressed, because it's a bit different from being part of the public service. So it's an interesting role.
Another question? Yes, please. No, sorry, on the right.
Sue Ogilvie from the Fenner School, just over the creek. My question would be contexted by your opening remarks about the means and the end, Professor Chubb. And what I would be interested in is if the end that we would like to see is an economy without debt, and that might be in economic as well as ecological and social debt, how would you design a science and environment program that would create an economy without those debts?
Well, I wouldn't see an economy without debt as the end game. I would say that that's a part of the process to get to be the country we want. I would like to see a country where in about, let's say 10 years' time, when the Treasurer is announcing the GDP growth for the country, as ours did earlier this week, that when he's asked to illustrate, he'll be able to say things, talk about things that we actually made, instead of identifying three things. The three things that were growing and supporting the growth figure was at 2.9% or something of that order. Education, tourism and iron ore exports were the three things that were nominated in that. Now, I'm not blaming him for doing that, I'm not criticising him for doing that, but I think that we should be aspiring to be a country that can actually produce things, make things, innovate, use the talent and skills that we've got to produce stuff that we can take into markets to make the world a better place as a consequence of having them available, and turn a dollar for Australia at the same time. Consequences of which are that we have a country that doesn't have debt. I'm happy to work towards a country that doesn't have debt, but I think that what we do need to do is to begin to think through about what the implications of it all are. I heard on the radio this morning, and I haven't had a chance to check it out, and I might have got the figures wrong, but something like 70% of the jobs that Australians do today didn't exist 20 years ago. It's going to be a very significant shift again over the next 20 years, and we've got to prepare now for it and work out what we want the country to look like. And if it's simply to be a tourism resource, we've got to look after the Great Barrier Reef. If it's going to be education, well, that's a pretty flimsy case to build when the rest of the world is, and indeed in our neighbourhood, are now teaching some of the advantages that we had teaching in English and so on, being swept up by them. So we need to produce things, we need to use our talent, we need to use our skills, we need to be secure in the use, we need to support them through the pipeline that's required. We need an education system that underpins it. We need a culture in the country that lets us take risk, by contrast with the present culture that is substantially infused throughout all that we do. And we need to change things. And then we can have a treasurer stand up and say, yep, high quality advanced manufacturers were the biggest growth sector in the economy, and they turned this out and we haven't got a debt anymore, and isn't that great? And that would be a good outcome.
Another question? Please, in the red.
Hi, John LaSalle, Atlas of Living Australia. I was interested, obviously, in your mention of big data as a future opportunity. I agree with you. Given that much of the science that we're talking about today is being government funded, I'm just wondering what the current feeling or thinking is on open data, making data freely, widely available, data management and plans for all this data that's being gathered in the environmental space.
Gordon, do you want to go first?
Thanks, John. I hope you know I gave you a plug. So I think the data issue, it's worth having a longer, frankly, and serious conversation around it. But just on the idea of open data, I think there's a very deep commitment from the government, and I think it's something that people naturally and instinctively share, is that data should be open and accessible, and that certainly one of the roles of government is to have data that helps inform the way we make advice, but frankly, more importantly often is that data and analysis and information is in the public domain, so that all decision makers throughout society are well informed, be that community groups, be that business, or be that research in institutions. So the whole shift to open data, that's I think a very strong drive within government, and I think that's something that people would also instinctively very deeply support. And then it comes down to the role of government again, that one of our roles really is to be credible information providers, and we've got to think about what that means for how we allocate resources internally, because we do work under a constrained budget, and we have to fit that. But it is a great thing to talk about. I don't know if that gets to.
I'll just add to it, and it's good to be sitting beside Australia's rational economist, because I can agree with everything that Gordon just said. I would add to it only by saying that there is a review of research infrastructure on at the moment that's was initiated by Minister Pine, and one of the outcomes of that, the consultation that's been involved with that, has been our not particularly effective approach to big data as a national resource that diffuses into everything, not defuses. So. And as Gordon said, I don't think there's any lack of commitment to open data and all the rest of it, and to collecting data. There is question marks about how so many different data sources can be used and brought together and made effective and useful for everybody who wants to get access to them. But I think that the review committee will be recommending that big data is a class of infrastructure almost on its own in this whole game, and that we've got to take a more serious and coordinated, coherent look at it to make sure that it does provide for the sorts of access that Gordon described, as well as more generally to the public, that they get access to inform their decisions, and that researchers can do. And at the end of the day, it's a rational thing, because we will minimise duplication, we will change the way we go about things, but it will require organisations to do things differently. I mean, you know, every department collects data, but they don't necessarily, you can't interrogate the data usefully for contemporary purposes in a lot of cases, because they're just long runs. So it's not going to be an easy thing to do, but the issue of having it available and having a national coherent approach to it, I think, is unarguable. The question then is how we go about it in the circumstances Gordon described.
Our time is done. It's 12:30. We are committed to finishing on time. I wanted to ask you to thank our two speakers for such insight from such a perspective, which is a unique and very special thing. Thank you very much.